In this lesson, we're going to be dividing rational expressions. The first one we're going to do is we're going to do something with just numbers so we can make sure we understand the concept of it. So if we have 25 over 36 divided by 15 over 24, we never have to multiply, or we never have to divide fractions, because I don't know what 25 divided by 15 is and 36 divided by 24. You don't ever have to do that. You can actually multiply by the reciprocal. So 25 divided by 36, instead of dividing, we can always multiply by the reciprocal. So we'll have to flip this. All right, so dividing by this fraction and multiplying by the reciprocal, they're going to get the exact same answer. So at this point, we're going to try to cancel out common factors on top and on the bottom. So, and they don't have to be directly on top of one another, because really this can become one big fraction, and it's those two pieces multiplied together. So we're trying to figure out what they have in common. So between a 25 and a 36, there's nothing in common, but a 25 and 15, we can divide a common factor of 5 away from both of them. So that would make that a 5 and a 3. And 24 and 36 actually both have a common factor of 12. So we can divide this by 12 and get a 2. Divide this by 12 and get a 3. And then I still look, does a 5 have any other common factors with the 3's? No. Does the 2 have any common factors with the 3's? No. So we don't have any other common factors left. So we just multiply the numerators together and we multiply the denominators together. And if you didn't have any common factors to reduce anymore here, you shouldn't have anything left to reduce here as well. All right, so that concept is exactly what we're going to be doing with rationals though. So we'll have something like this. X minus 11 squared over 2 divided by 2x minus 22 over 4. All right, so what we're going to do is we're going to multiply by the reciprocal. So this x minus 11 squared over 2, we're not going to divide, we're going to multiply by the reciprocal, and at the same time I'm going to factor that. So because that's going to go into the denominator, but I might as well factor it at the same time. So I'll divide a 2 out, that'll leave us with an x minus 11. So that is going to go into the denominator. Okay, so now we're going to try to reduce as best we can. And I see that they both, on top and bottom, have an x minus 11. This one actually has two x minus 11s. So one of these will cancel one of those, leave you with a power of 1. And then I have a 2 that divides into the 4. That'll become a 1. That'll become a 2. And that 2 divides into the 2. All right, so we got to figure out what we have left. We have left an x minus 11. Everything else went away. And then everything reduced on the bottom as well. So we just have an x minus 11. All right, so let's do x squared minus 16x plus 60 divided by x minus 10 divided by an x minus 6. All right, so I'm going to rewrite this, but I'm also going to factor this at the same time. Might as well. So this factors into what multiplies to 60, that adds to negative 16. So x minus 10 and x minus 6 divided by x minus 10. So I see a common factor that I'm going to be able to reduce by. And then instead of dividing by this, if I need to, I can put this over 1. So because I'm going to multiply by its reciprocal, so I'm going to flip this. 1 over x minus 6. And I have the x minus 10s cancel and the x minus 6's cancel. So I'm left with a bunch of 1's multiplied together. So I have 1 times 1 times 1, 1 times 1. That's just going to be 1 over 1, which is just 1. All right, last one. 9 minus 3x over x squared minus 9 divided by 1 over x cubed plus 27. Okay, so very first thing I see with that numerator of the first fraction, this one right here, I don't like that my x is not at the beginning of my expression, and I don't like that it's negative. So I want to rearrange that. I want to clean that up a little bit. So I'm going to divide out a negative out of it, and I also see that a 3 can divide out of both of them. So if I divide this by a negative 3, the x will actually become positive, so I'll put it first. And then if I divide a 9 by a negative 3, that'll make it a negative 3. So I'm just rearranging the order a little bit. And then this I need to factor, so that's going to be an x squared. Oops. That is a difference of squares, so that's going to be an x plus 3, x minus 3. And then this is a sum of cubes, so there's a pattern, a formula for this. And so that's going to be the cube roots of these, which is x plus 3. And then my signs are locked. I have same, opposite, always positive. My first term is going to be the first term times itself. My middle term is going to be the combination of these two. And my last term is going to be the last one times itself. All right, so let's clean this up. And instead of dividing, we're going to multiply. I'm going to put it down here. So my first fraction, I'll write the factors. And then my second fraction, I'm not going to divide, I'm going to multiply by the reciprocal. So I'm going to flip this fraction. So this piece that was the factor of this now becomes the numerator. X squared minus 3x plus 9. And then this becomes the denominator. So from here, what do I have in common on top and the bottom? I have x plus 3's that can cancel away. I have x minus 3's that can cancel away, become 1's. And I don't have anything really left in the denominator, so I'm going to get, I'm not going to get a fraction anymore. It's going to be similar to these two where I don't have anything left in the denominator, and I have a negative 3 times x squared minus 3x plus 9. And if you want to distribute that in, you can, but you do not have to. All right, and that was dividing rational expressions.